AB Calculus Note Card 55, Trigonometry Integration Formulas. This is the 55th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed the note card system. I hope you can recall from note card lesson 16, we looked at the derivative of sine x and also of cosine x. And I'm going to go over this in a minute, what those were. And also in note card lesson 22, we went over the derivatives of tangent x, secant x, cotangent x, and also cosecant x. And so these formulas here, 6 of them are going the opposite direction. And of note, I don't know if you have seen this or not, but as far as the derivative, how to find the derivative of sine and cosine, there's this thing called snow code Santa Claus, where if you derive, you go in this direction. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, and finally the derivative of negative cosine is sine. What you're doing, instead of going in this clockwise direction, when you integrate, you can use the same diagram, but just go the opposite direction. And so we go counterclockwise for the integration. And so it's the same type of organizer. So we're going to use that and use all these formulas in a few problems we're going to view here. The first one, the integral of 2 sine x dx. Well, we're going to use, first of all, our properties of integrals to take this 2 outside the integral symbol. And so we go sine x dx. And then going back to our little diagram here on the right, in integrating, we're going the opposite direction. So we're going like this. And we want to find the integral of sine. And to do that, we go to negative cosine. And so our answer is going to be here, we'll bring this negative sign out front, 2 cosine x. And then we have to remember, for an indefinite integral, the constant of integration c. So we're going to have to add our c out here. And that's going to be our answer to problem number 1. Problem 2. We have the integral of pi secant squared theta minus cosecant squared theta, and it's not clear from this, but the intention here is to parenthesize everything before the d theta. And so what we're going to have here is, I'm just going to simplify things. I'm going to bring this pi out front of this first one and get secant squared theta minus, and I forgot to, secant squared theta d theta minus the integral of cosecant squared theta d theta. Okay, so now we've separated it out. Now we can kind of work backwards from what we did in Notecard 22, but just looking at the formulas here, we have the integral of secant squared x is tangent x plus c. The integral of cosecant squared x dx is negative cotangent x plus c. And these are things you're going to have to remember, and there are things you can do to put these together, and I'm going to explain that toward the end. So for this first one, we're going to get pi, and we're going to get tangent theta, and that's going to be plus c. And then what we get, the integral of cosecant squared theta d theta is going to be negative, and so we're going to have a negative negative, so we're going to have plus cotangent theta. And then we have our constant of integration plus c. And one way to look at this, I don't know if you remember, again, secant, we had tangent, secant, secant. So working the opposite direction, if we take the integral of tan, if we cover this up, we're left with secant squared, meaning that the integral of secant squared is going to be tangent. And then we also had this negative cotangent, cosecant, cosecant, and the derivative of cotangent is negative cosecant squared. Therefore, the integral of cosecant squared is going to be negative cotangent. And that's where we reverse this sign here. So something really that you'll have to remember, but I hope that having worked with the derivative so far, you have a sense of familiarity already. This problem 3, we have the integral of quantity 3t squared minus 1. Well, there are different ways to do this. You can actually do a chain rule thing or a u substitution. What I like to do something like this is just expand first. And I don't think we've gone over u substitution yet. So if you have a binomial squared, quantity a plus b squared, that's going to be equal to a squared plus 2ab plus b squared. So I'm going to use this format and just rewrite this integral, and in the place of a we have 3t squared, so that's going to be 9t to the 4th, and then we have plus 2ab. Well, what we're going to get is we're going to have negative 1 times 3t squared, and that's going to be 2 of them. So negative 1 times 2 times 3 is going to be negative 6 t squared, and then plus b squared. Well, negative 1 squared is 1 dt. And now we can just split this up. We're going to have 9 integral of t to the 4th dt minus 6 times the integral of t squared dt plus 1, and for 1 I don't write anything, dt. And our answer for this is going to be, we bring out the 9, and then we have t to the 5th power, and then we divide by the power that we raised, t2, and we're going to have minus 6 t to the 2 plus 1, or 3, and we're going to divide by 3, and finally we're going to have plus t plus c. And then finally, we're just going to simplify one more time. We have 9/5 t to the 5th power minus 2t cubed plus t plus c. So even though this problem finds itself in the section that has to do with the integrating using the formulas of trigonometry, this is not one of those, but we didn't need that, so it's just one thrown in there. Problem 4, multiple choice. The second derivative of f is given by f double prime of x equals 2x minus cosine x. Which of the following could be f of x? Before this, I'm going to go back to what we did before twice. Snow cone Santa Claus. And when you go back to an original, you're going twice. And here, integrating, we're going in this counterclockwise direction. The direction of integrating. And so, to get after a second derivation, it's going to be, if one of these is the original, it's going to have to be another cosine, because if you go 2, you get to a negative cosine in this case. If you go from here twice, you get, so these ones with sine that are going to be answer choices D and E automatically eliminated. Let's go work this out. Okay, we're just going to work out the rest of them. I'm going to come down here. So f double prime equals 2x minus cosine x. So f prime is going to equal the integral of 2x minus cosine x dx. Okay? And the integral of f prime is going to be, we have 2x squared over 2, and what is going to be the integral of negative cosine? Well, it's going to be negative sine. So it'll be negative sine, so it's going to change to sine x plus c. That's going to be f prime. And so f is going to be equal to, we go ahead and without the integral of x squared plus sine x plus c. Okay, and that's going to be, but we don't have to put the plus c because we're going to end up with an arbitrary c anyway, so I'm just going to leave the c out of there, dx. And working to the right, the integral of x squared is going to be x, let me just write f equals x cubed. We're going to divide by 3, and the integral of sine is going to be negative cosine. So I'll put minus cosine x and plus c. And what do we have? We have here, it's going to be either a or b, and okay, let's see what we have here. Well, C, looks like that could be it, because we got minus cosine x, and this could be x because we end up with this C here, so it's going to have to be answer choice B. So just a few problems using integration formulas. I hope this has been helpful to you. Good luck. and thanks for viewing.